So here is another question on sum of n terms of an arithmetic progression. So it is given, if the sum of the first m terms of an AP be n and the sum of the first n terms be m, both lowercase, then show that the sum of its first m plus n terms is minus m plus n. Okay, it is confusing, but okay, let's do it. So let's say for this given AP, we have the first term is A and the common difference is D. So here we'll be using the basic nth term formula. Here I will be using an uppercase to denote the formula. So sum of first n terms is equal to n by 2 2a plus n minus 1 into d. This is the basic formula. So here it is given that the sum of the first m terms of this AP is equal to n, and the sum of the first n terms, that is equal to m. So if we write it in a proper way using this formula, so we have m by 2 into 2a plus m minus 1 into d is equal to n. Okay, this is for Sm is equal to n, and then we can write it as m into 2a plus m minus 1 into d is equal to 2n, or that implies 2am plus m into m minus 1 into d is equal to 2n. This is, let's say, equation 1. Then we use the next one, that is Sn is equal to m. Okay, this is Sm is equal to n, this is Sn is equal to m. So that implies n by 2 into 2a plus n minus 1 into d is equal to m. That implies n into 2a plus n minus 1 into d is equal to 2m. That implies 2an plus n into n minus 1d is equal to 2. This is equation 2. Now, if we write these two equations separately, okay, we take, let's say, 2am plus m into m minus 1 into d is equal to 2n, and 2an plus n into n minus 1 to d is equal to, sorry, this is 2m, this is 2n. Okay, this is 2m, this is 2n. Okay, here again, this is, yes, this is equal to m. Again, always be careful because silly mistakes like this can happen. Okay, mn, this confusion can happen, so it's very common. Okay, so this is 2m. Okay, so now we'll perform the subtraction. Minus, minus, minus. So here we'll write it as 2a into m minus n, okay, then plus, here it will be, we'll take d common, and we'll write it as m into m minus 1 minus n into n minus 1, and here it is 2 into n minus m. Okay, so now we can simplify it as, that implies 2a into m minus n plus d to m square minus m minus n square plus minus n square plus n. So here it is m square minus m minus n square plus n. Okay, that is equal to, here we can write it as minus 2 into m minus n. Okay, same thing. So now we have, okay, that implies we can write it as 2a into m minus n plus d, so plus d into m square minus n square minus m minus n. We write it in this way. Okay, m square minus n square minus m minus n. Same thing, minus minus will become plus, minus m plus n. So this is equal to minus 2 to m minus n. So that implies 2a into m minus n is equal to, plus, okay, not plus d into, here we'll factorize it at m minus n into m plus n. A square minus b square is a plus b into a minus b, that minus m minus n, that is equal to minus 2 to m minus n. So here throughout m minus n we can take common. So that implies m minus n into 2a, here 2a, here plus d into m plus n minus 1, here see m minus n into 2a, here m minus n, here m minus n, okay, and here m minus n. We take common. So if we take m minus n common here, it will be d into m plus n minus 1. So throughout I have taken all total together m minus n into 2a plus d into m minus n, m plus n minus 1, that is equal to minus 2 into m minus n. Okay, it's all right. Okay, m minus n into 2a plus d into m plus n minus 1 is equal to minus 2 into m minus n. Now we cancel m minus n on both sides. So we have, that implies 2a plus m plus n minus 1 into d, that is equal to minus 2. Okay, 2a plus m plus n minus 1 into d is equal to minus 2. This is the important relationship. Now it is asked in the question to show that the sum of its first m plus n terms is equal to minus whole m plus n. So again we have to use the nth term sum formula. So we have, we'll keep this relationship here, and again going back to the formula, the sum of the first n terms, let's say it is equal to n by 2 into 2a plus n minus 1 into d. So here for sum of first m plus n terms, for that we'll take n is equal to m plus n. So here Sm plus n is equal to m plus n by 2 into 2a plus, here instead of n we have to put m plus n. So it is equal to m plus n minus 1 into d. Now here we just establish this relationship where 2a plus m plus n minus 1 into d, that is equal to minus 2. So this whole part 2a plus m plus n minus 1 into d, this becomes minus 2. So we have S m plus n, that is equal to m plus n by 2 into minus 2. So this becomes minus 1. This is equal to minus m plus n. Okay, so the sum of the first m plus n terms, that is equal to minus m plus n. We proved it. Okay, again using the same nth term formula, nth term sum formula, we took what was given in the question. Okay, sum of first m terms is equal to n, sum of first n terms is equal to m. We made some adjustments and got these two equations. Then we performed subtraction to establish this relationship where we took m minus n common and established this relationship, which is equal to 2a plus m plus n minus 1d is equal to minus 2. Then we again use that formula to find out the sum of the first m plus n terms. We use this relationship and we proved Sm plus n is equal to minus m plus n. Okay, so this is the thing. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.